Hello good day viewers, welcome back once again. Please kindly subscribe to my channel, also like, comment and share. In this video we are going to find a solution to this problem here. We're going to evaluate this improper integral. We have the integral from 0 to infinity, the natural log of x divided by 1 plus x squared dx, and we have some restrictions here. We are not going to make use of power series and special functions, right? Now let's see how we're going to do this. This integral, I'm going to call it I. So here I have I is equal to the integral from 0 to infinity, the natural log of x all over 1 plus x to the power of 2 dx. From here, I'm going to make the following substitution. I'm going to let x equals 1 over y. From here, if you solve for y, y is actually equal to 1 over x, right? So from here, let us try to differentiate both sides. So from the left, we have dx is equal to, now the derivative of 1 over y with respect to y will give us negative 1 over y squared, and here we have dy. So here I is equal to the integral. Now what about the boundaries of integration? You know, when x is approaching 0 here, y will be approaching 1 all over 0, and that tends to infinity, right? So here we have the lower limit as infinity. Now the upper limit, you know, here when x is approaching infinity here, y will be approaching 1 over infinity, and that tends to 0. So from here, we have the natural log of x. You know, from here, the natural log of x in terms of y, from here, is going to be the natural log of 1 over y, right? And you know, this is equal to the negative natural log of y, right? So here we have the negative natural log of y, then all over, from here, 1 plus x squared is 1 over y squared. Then we have to multiply by dx, which is negative 1 over y squared dy, right? Okay, so from here, I is equal to this negative sign. We're going to write it out, right? So here we have negative integral from, now we're going to switch the limit, and this negative sign will cancel out, right? So here we have from 0 to infinity, the natural log of, now we have to change that variable y to x because it serves as a dummy variable, right? Then all over, you know, y squared will multiply this, the whole denominator here, right? You know, y squared times y here is y squared, and mind you, we're changing it to x, so here we have x squared. Then plus 1 over y squared times y squared, that will give us 1. Then dy will become dx. Okay. Now let us recall again that our I is equal to this integral right over here, and we also have I here to be this integral. So the idea from here is to add both integrals together, right? So here we have I plus I will be equal to the first one here, the integral from 0 to infinity, the natural log of x over 1 plus x squared dx, then plus the second one here, let's put it in brackets, that is the negative integral from 0 to infinity, the natural log of x all over 1 plus x squared dx, right? Okay, so from here, I plus I will give us 2i, this is equal to the integral from 0 to infinity, the natural log of x over 1 plus x squared dx. So plus times negative here, we have negative integral from 0 to infinity, the natural log of x over 1 plus x squared dx. So here we have 2i is equal to, you know, this minus this, that will give us 0. So divide both sides by 2. And from here we get I is equal to 0 divided by 2, which is 0. And this is the right answer. Thank you for watching. Please kindly subscribe to my channel. Also like, comment and share. Bye bye.